Man, we're back. We are COMP1004 and the winter 2017 semester, week 9, part 1 of our broadcast, rapid application development at Georgian College. Whew. Crazy stuff. I can't believe we've come so far. On the schedule today is, again, we have more about database. And what I'm going to do now, just so that we can get this done, is up online. Let me just log in here for a second. So in our course, what I want to do is in our weekly learning, I want to drop in a couple of PowerPoints that we're going to be talking about today. It's actually quite important stuff that you will need to complete your, well, the concepts will help you complete your assignment, which is what I really want to happen. All right, that's really what it's all about. So Georgian. Yeah, so I got a couple of them. I got how to use link and what link is, right? And I also have the other one, which is how to use entity framework, which is what we're going to talk about today. Link and entity framework. So you talked about last week with this one, and I'll add more here, so I'll keep this open. Last week we talked about the way that this stuff that I showed you is the old way, right? The stuff that I talked about when we connect to data, right? We connect to, if we use ASP.NET's way of getting data sets, using data sets last week, we do it the old way. That's the old way of doing things. Typically, we don't use data sets anymore. What we do is, I think it's this one first, we use another means of connecting, right? And this is the wrong one, of course, Tom. What are you bringing up? It's this one. So there's two parts to this lecture. One of them is link and what that stands for, right? Which is what this part is, how to use link. And the other one is how to use entity framework. Link in the entity framework. So what is link? So really what you want to think about is, so when it comes to link, we normally have these clauses when it comes to, when we kind of connect to any kind of SQL server, right? We have things like from, where, order by, select, all those things that are part of the query string, right? We make a query string to select or do something with the database to access the database and to get information from the database. Doesn't matter whether you're using SQL, Microsoft's version of SQL, or MySQL, the open source version that we use with PHP and so on. Either way, we have all these clauses that we use when we connect, right? It's part of our syntax, our language that we use to access the database. With link, this is something called, it's a little bit of a language that we can use to query the database without using clauses, but what we're using is something like methods. Let's think about methods. So instead of, if I want to do select, I can select as a method as opposed to a big link, a big query, like a string. Normally a query is a string. We take it, we put it into a statement, we prepare the statement, we execute the statement on the database, and it comes back with the results. We can fetch something from the database, and then from there, after we fetch information from the database, we can do something with it, right? But basically, what this is it's a query language that's integrated with C#, right? So C# helps us wrap our query inside of another class. Make sense? Anybody? Right? So that's one thing we're going to use. So we're going to use link to access, to use entity framework. And we'll talk entity framework after this. All right. So again, there's a couple, 3 stages that we talk about here when it comes to some kind of query operation. One of them is somehow get access to the data source, right? So if a data source example is an array, and by the way, you can use link not just to connect to things like a database. It can be an array, it could be an Excel spreadsheet, it could be a text file, whatever it's going to be, right? you must declare the array and then assign values to its element if it was that, right? 2, define the query expression. Now, normally, like I said, use query language, select star from table, whatever the table is, right? Where ID is equal to user ID. That would be kind of a query, right? Execute the query when we get the results, right? Those are the kind of the operations that we normally make, right? So here's an example of that. So here's our code that defines an array if we're going to use an array. So here's an array of numbers. By the way, last week I put up a little PowerPoint for your use to take a look and see how arrays are formed in C#. Again, very similar to what we see in Java. So I'm not going to go over all the syntax, but here's a good example. Int with square brackets indicates that it's an integer array. The name of the array would be called numbers, right? In this particular case. So I'm just make this a little bigger for you guys. And then what we're doing is we're declaring an array of a fixed size. It's immutable. Once we declare an array, the one thing different between an array and a list is that arrays are immutable. Once you define their size, they always stay that size, right? So we use the new keyword, and we declare a new integer array of 6-member size. That's how big it is, right? And then we loop through it for int is equal to 0, right? We start at 0, and then and again, this is not recommended to do numbers.length in the iterator, right? Because that means it's going to calculate. This is a calculated value, right? We calculate this value every iteration, right? And it's better for you to make another variable name, put that outside the iterator, right? Like, for example, numbers length would be a variable. Int numbers length is equal to numbers.length. You do that one time, right? And then inside the for loop, you just put that calculation result, right? So it doesn't take up a lot of calculation processing, if you will. So then we iterate through. We increment the iterator. So for, again, this index, we're going to increment. We're going to start at 0 because we use zero-based counting for C# and for Java and for most modern languages, right? And we start at where a 0, the 0th member is going to start off with a value of 0. And in this case, we're going to the member itself is going to equal to the value as it counts up. It's going to equal to 1, 2, 3, 4, 5 as an example in 6. Or 1 to 5, 0 to 5. A statement that defines the query expression would look like this now. So instead of a regular query where we have in quotations a string, our new query using link would look like this. From, we actually use the from keyword, right? Number, which would be it's a type. It would automatically infer what kind of type it is based on the numbers collection. In this case, the collection is an array. For number, from number in numbers, where number, and then %2 means it's mod. So modulus, number modulus 2 is equal to 0. That means where every other number, right, without a remainder, or remainder is 0. Where when we take a number and divide it by 2, the remainder is 0. That's what it means, right? Order by number descending, so descending format, right, from greater, from the highest number to the lowest number, and then select that number means that's the number you're going to return. That's the new format that we use, and we use link for everything, right, when it comes to ordering data. And this is a good example of that. Do I have to use link? Hell no, I could use SQL, right, structured query language if I really want to. But it's not what we do in C#. In C# we use link, okay? We use link because it's more efficient. You can do things like use it as a method. You could also just use it just like this as keywords. So the keywords themselves, once you can collect this, notice that we're using a var. When we talk about var, var is like the auto keyword in C++. It's in many ways what it does is it says, hey, I don't know what variable type this is going to be. I don't know what it's going to be. It's going to probably be a list that I'm returning, right? But what I want you to do is I want you to do this whole statement, right? And then by using type inference, by looking at what the result is going to be, what you're assigning to the number list, I'm going to tell you what the type is going to be. That's what var does. It is not like var from JavaScript. I just want to reiterate this, right? var in JavaScript is it's a dynamically typed language. It's loosely typed. It doesn't matter. Number list could be this, and it could be something else later on in JavaScript. Not so in C#. In C# and in Swift and other languages that use type inference, once you assign a value and it declares what type of value it is, it's that kind of value forever, right? It's always going to be like that. And so it is strict typing. It's just using a way of determining the type as opposed to us explicitly telling the compiler what type it is. Okay? So the codes that executes the query. So first we get the number list itself is the result of the query, right? It's a list of numbers from the numbers array that matches my query, right? So in this case, I'm looking for numbers that are even numbers, right? And if I have numbers from 0, does 0 match the result? 0, is that does it? 0% 2, 0 divided by 2, is that equal to 0? That might match the result, actually, believe it or not, if you actually try it out, right? So 2 for sure does, 4, and there's no 6, so it's like, it could be like 0, 2, and 4 potentially, right? If 0 would match the result. String, my number display is equal to empty string. For each number in number list, again, we're iterating through the entire array. Then number display, which is a string, would be equal to number. So we're adding a number plus a couple of tabs. That's what we're doing. So these /t is tabs. That's they're tabbing into the string itself. They're moving our cursor in the string, and then add in a new line at the end, right? So it's going to add a new line at the end of each number. So that's pretty cool. So that means it's just going to show us what's in there, and then we're going to use the messagebox.show to display the number, and then we're going to say sorted even numbers. So that's what we're looking through. So this is the way we can do that. We can use this thing to search through our numbers, get the numbers we want, and return them. And this is a more efficient way of doing this instead of doing something like this. Switch number in numbers. And then what is it? If it's this, then do that. If it's a this, then do that. If it's a this, then do that. Or if run it through a for loop and say, if this number is equal to this, then it matches the criteria. I don't have to do that. All that's being done here inside of my statement. So again, the syntax that we need when we use link, we use from, the keyword from, whatever the type is. So in this case, it might be an integer or a list or something. And then the element name in the collection name, all right? So an example would be, and by the way, when you see square brackets like this, it means optional. You don't have to put the type in if you don't want. It'll figure it out, right? So here's an example, decimal array, sales totals, right, is a new decimal array. And we're using initializer syntax here. Curly brackets after the decimal is actually initializing the members of the array. So even though it says 4 explicitly, I have 4 members, I'm initializing their values. Each member element is going to have the 0th element is going to be 1286.45 M. M, you have to use M with decimals, right, to denote member, because decimal is a real number, right? And there's different types of decimal. There's a double, there's a float, and there's a decimal, right? Double, float, decimal. Double precision, float, single precision, decimal. It's even more precise for numbers, right? And then the 0th, the 1st, the 2nd, and the 3rd element. These are the values, right? So this is the array. And then we say, well, we're using the var keyword, right? So we don't know what type it's going to be. Our sales list is equal to from, that's the keyword, right? From sales, which is the element name, in the in keyword, sales totals, which is the collection name, that's what it is. And then we're going to use the select statement, in this case, to select all the sales. So what I'm doing is I'm saying, give me all the numbers from the array. That's what this is doing. It's not really, I'm not saying where this number is equal to so-and-so, which means when I use a select statement like this, it means it's like selecting star from a query perspective, right? Fantastic. And then what I'm doing here is I'm saying, well, let's set the sum to 0, and for each var sales in sales list, then add up the sum for the total sales. So this iterates through the entire list and adds the sales up together, right? Again, we're using this link to query an array. That's just the data, right? But we can query any data, including, but not limited to, a database, right? Which is very useful. Okay, here's an example that uses generic list of invoices as the data source. This is a little different, and this is why I wanted to do this little learning with you today, right? So I've got a class invoice, right? Remember, a class is just a blueprint, and I have several different properties in the class. They're all public properties. Notice that I'm using the getter, setter, initializer syntax here. So it's automatically making these things public properties. So I've got invoice ID, customer ID, invoice data, product total, sales tax, and so on. And then what I'm doing is I'm creating a new list of type invoice. There's the invoice class. That means I'm making a list of objects, invoice objects, right? And then I'm calling it invoice list. When I just do up to there, if I just stop there, just do this part, I haven't really created anything yet. I'm just creating a shape. I'm setting aside some memory, I'm putting it aside, saying I'm probably going to need this memory in a bit, right? Put this memory aside. I haven't really used the memory. Memory's empty, right? And then when I do this, invoice db dot get invoices, okay? Here's my invoice database, right? So let's say I have access to an invoice database in this particular case. Get invoices might be a method that I'm using to load my invoice list, whatever that invoice list is. I might have a list of invoices with all this data. Each of the invoices are going to have this. I don't know how many I have. That's why I'm using a list. And it's like a linked list. So one list is, it's not an indexed value. It's not like an array. And by the way, we use lists far more in C# than we do arrays because of the flexibility, right? So here's an example of this. And now I'm going to do the query. So my invoices is equal to from invoice in invoice list. Going back to the invoice list. Let's say I had a list and somehow I got the invoices. I don't know how I got them. This method here, who knows what that is? But we don't care. All we know is it's going to load a list of invoices and put it into invoice list. So there's going to be a bunch of invoices there. Right? Who knows how many? Right? We don't know. It could be 10. It could be 10 million. We don't know. Right? And now what we're going to do is we're going to use this query statement to loop through or search through the entire invoice list and select everything. This is returning everything because I'm not filtering in any way, right? I'm not saying where it's equal to this. I'm just saying return it all, right? And then I'm adding up. And let's suppose that my invoice, notice I'm using a property called invoice total. Well, that's coming from the invoice total property right here. So each of the invoices has a property called invoice total, which keeps track of the invoice total for that particular invoice. I'm adding them all up together and returning the sum of all the invoices. That's what's happening here. Is that clear? This is another example. Okay, let's try that again. The where condition. So again, just like you did with if you're doing things with databases, the where condition is very, very important here. It filters. Right? That's what it does. It filters our list. We don't just return everything. Here's an example where from the sales totals, where sales are greater than 2,000. Only sales that happen to be greater than 2,000 are the ones that are returned. Right? And that's a way of doing it. You can say, okay, I only want sales greater than 2,000, or I want sales that are greater than 2,000 and sales that are less than 10,000. So a range of sales, right? I want to filter on. And of course, I can make these things, like we've seen before, variables, right? The actual values can be variables because I'm not using query language here, quotations. I'm using syntax, a link syntax to do this, right? All right, so code that executes the query, again, so I'm going to say string my cell display, whatever the cell display is, I loop through it, and then I show it, okay? And by the way, once I start getting my sales list together, right? Once I do this, I actually execute the query, believe it or not. As soon as I want to see what my sales list is, or once I do this, the code is executed. Query is executed. Here's another example, that invoice we just did earlier. And here a query expression that returns invoices with totals over $150, right? So I can say where invoice.invoice totals greater than 150. Same idea. Order by. You can do ascending or descending. Again, you've seen this before where I can say where sales are greater than 2,000 and order by sales, right? In this particular case, it's ordered by, it's ascending by default, right? And you can also change it to descending if you want. So you can just the order that it's displayed in, the sort order. I'm not going to go into too much more about that. And this one sorts a generic list descending in the opposite order, right? All right, select. And my select statement is kind of important because I don't have to select everything, I can only, if I want to, I can only return certain columns or fields from a list, right? So I can return only, for example, in this case, property name 1 and property name 2. I don't care about all the property names. And notice the syntax here, right? Where I have a new keyword. Again, I can specify the type if I wish, but it's optional. And as long as I use the curly braces, that's required. Then I can specify the property name, any property name that I want to return, right? With a particular expression that matches an expression. Here's an example of that, right? Here's my sorted list. This particular case is a sorted list that has key value pairs, all right? So in this case, I have the string and a decimal, which I call employee sales, right? Notice that I have an employee, which is the string part, equal to a decimal value, right? That's what it is. That's what it holds. So key value pairs, a sorted list. That's the type that I'm using, and it's a built-in type, by the way. And then what I can do is I can say, well, this number, I'm assigning this number to this particular element, right? Which is called Anderson or Thompson. And these are more contextual elements, the way we're doing it here for a sorted list type. So that way you don't have to, you almost like the list itself takes care of, you know, each of these objects, what they mean, right? Okay, here's an example of how we do this. We can say, well, my employee list is from sales and employee sales, right? That's what we're looking for, sales and employee sales. Where sales.value, and again, employee sales, notice is a sorted list. Where sales.value, so the value of the object here, that's the value part of the equation, right, is greater than 2,000. So it's going to take this one, and this one, those three, right? Menendez, Thompson, and Wilkinson match those three values, right? Order by sales.value descending. So it's going to start off at 2893.85. It's going to go down to 2433.49 and finish at 2094.53 in this case. And then select the sales key. Okay, sales key is this part, the name of the object. So it's going to return the object, the sales key with these values, right? So it means it's going to not return the value, but rather return the person with the highest sales. So in this particular case, it's going to say Thompson instead of the values, Thompson, Menendez, and Wilkinson. That's going to be the value that it's returning. Okay, cool. So I'm returning the value, and then I say for each employee in employee list, display the employees that match that criteria. So here's the employee list display, sorted employees with sales over 2,000. It's going to show those people's names, right? So again, a more complex example, but again, it's very similar to what we've done before. Okay, here's something we can do. We can say for invoices from invoice in invoice list where invoice.invoice total is greater than $150, order by invoice.customer ID and invoice.invoice total descending. So we're looking at those two things, and then select both customer ID and invoice total to return. That's all you're returning. So you're sorting by this, ordering by this, and returning those two things. Customer ID and invoice total. I can return only two things, not the entire record, right? I can either return the entire record or only part of the record, which is really, really good control, right? And here's another example. We can do joins and so on. I'm not going to go too much further into this because I'm not going to ever ask you to do joins, right? But if you ever want to, the information is here, where I can kind of create an invoice list and a customer list, and then I can do a foreign key and kind of mix between the two together. But let's just do this example to follow through. So I've got a customer, and it has a customer ID and a name. That's two properties. And then I got two data sources here. So the reason what I'm doing here is I'm joining my element name in my collection name on a particular key, which equals this key name, right? So I've got a list of type invoice. We already saw that. We're going to get all the invoice lists. And we have a list of type customer. This is the customer list, right? Where my customer DB, I'm accessing my customer DB and getting all the customers. So I got both customers in this customer and invoices in the list, right? Remember that customer ID is here, as well as, if I go way back up where we define that list of invoices, I think it's here. I have customer ID here too, right? So I've got my foreign key. This would be the foreign key example, right? Sorry, it's down here, right? So I got those two things. So I got a foreign key. So customer ID does match, right? And then what I can do is this. Here's my query, right? From invoice and invoice list, right? Join the customer in customer list. So take a look at the customer in the customer list. Do that. It's almost like I'm doing a join. And on invoice from the invoice list dot customer equals to customer dot customer ID. So I'm matching my foreign key with a key that I'm getting from the customer list. So I'm saying where my customer is equal to the customer list ID that I'm getting from my customer list, right? Where my invoice total is greater than $150. So customers with an invoice total greater than 150 is what I'm getting back. Order by my customer name and my invoice total in descending order. So the ones with the highest invoices outstanding. That's what I'm looking for, right? And then I'm only selecting my customer name and my invoice total from that. So I'm looking at just the customer name and the invoice total that I'm returning. So again, very complex. It can be very good syntax to return whatever you're looking for, right? Does anyone not understand what I'm showing you? So link. Link is one of the things we need to use when it comes to entity framework. This is the first part of what we're doing. And this is how you display it. Okay, I'm not going to do that anymore. So far we've been doing, we've got a class that says with an extension method that formats a phone number. I'm not going to do this one with you guys, but here are the main ones that you should know. So where, order by, select, and join. Those are the four basic keywords that we use when we use link. And we need link in order for us to query our database. I can do link right now. I can use link with the way we did it from last week when we got our data set, right? I can use link again. I can add link in there, and I have to use a using statement, right? Where I use system.link, right? Because it's not a library that's automatically loaded when you use C#. You have to load it in, right? Because it's C# is kind of a compartmentalized language like other modern languages like Java and C++. And so on. We kind of add on to it when we need to, and we keep it as lean as we can throughout the time that we use it. Questions around link. Again, if you want to access it, just went through all the examples here, very basic examples. We're going to be using link with entity framework. I can't do entity framework without talking about link. They kind of one goes with the other. Right? That's why I'm doing it. Okay. All right, we're going to get back to this in a bit, right? Actually, I keep it open for us because we're going to need it later on. Okay, that's one. Part two. What am I talking about when I say the new way? I'm always talking about the new way, the new way. What is it? Not a lot of slides here. But we want to talk about the entity frameworks. What is this? It's something called an object relational mapper. Okay. So we have a relational database. And what I'm doing is I'm wrapping the way I'm connecting to the database with something called the entity framework. The entity framework is almost like a bunch of adapter classes that I can use to connect to my database. And of course, I'm going to use link to access the data that I get from it. Okay, that's what I'm doing. So the object relational mapper, basically, it allows us to do a couple things. It allows us to scaffold something that we want to call a model class. Okay, why am I talking about model class? Well, it goes through this whole idea of model viewing controller, the separation of concerns, right? Which we're going to get to in a bit. I'm mentioning it, and I'll come back to it in a second. All right, so the idea here is that one of the benefits of using this thing is development time is reduced because the entity framework was made by developers for developers. It says, hey, you know what? We always do these operations all the time. And most of the time, what do we always have? Just hands up for you guys to tell me. Do you think we typically create our own database when we're in industry, or do you think that we link in or tag into a database that already exists? What do you think is more common? So am I tapping into a database more often, you think? Well, just by intuition, you may not know, but what do you think? More often do I tap into it, or do you think I would create my own? Tap into it, right? That means it's being managed and owned by somebody else, not by me, right? I have to connect to it somehow, right? Okay, cool. So that means there's a couple scenarios. One, I'm making a whole new database, number one. Two, I also want to define a class, some kind of class, that really defines each of the tables in the database, okay? Because just like I did with the invoice class from my previous PowerPoint, I'll go back to that for a second. So if I go back to my invoice class, which is way up here, I think. Oops, that's too far. There. So this is the invoice class, right? Notice this invoice class, I'm just going to bring us a little closer. It's just a class, right? But it describes a table. This could be a table, right? These are my fields in the table or columns, right? That's what it is. So I want you to always think about this kind of class, if it was in a database, as a model. This is my model or schema, if you will, for each of the records in my table, right? That's what it is. So whenever we look at a model class, it would look like this. Okay, cool. Now, normally what I'd have to do is actually create this myself. I have a data store somewhere online. I've tapped into it. It's not even mine. I don't own it, right? And I got to tap into it. And I got to describe my class by myself. I have to actually code this thing on my own, right? But why? Because it's exactly the same thing. Every single time I'm trying to match the types as carefully as I can with the database. What if I don't have access, physical access to getting in there and accessing the database more than just looking at it, right? I can't modify the structure. I'm not allowed to, because most times an administrator takes care of that, right? The only thing I can do is kind of look at it a little bit, look at the structure. Well, Entity Framework will do that for you, right? It'll actually look at the structure. It'll analyze what kind of structure it is for each of the tables and code the class itself for you. And that's what the reason is. It's way more powerful than you trying to do it on your own, because I'm going to have to hand bomb all the classes. Can I do that? Sure, I can make my own classes and to represent the tables in the database. I could do that. But why? And why would I want to make classes? Because I want to make objects. Because if I make objects, I've been showing this whole semester. You make an object to pass the data from one user interface to the other. You make an object to pass data from the user interface to the database. You make an object to pass the data from the user interface to the file, right? The file system. You always use an object because you know what? You can play with many objects much easier than if you play with a few properties that are loose, that are in the wind, right? It's much more difficult to do that. All right, so let's go back to this idea of the entity framework here, right? So why do we make it? For developers, by developers. It was made for us to quickly scaffold the classes and the whole structure of your data access for you. It was made for that. Okay, and we're going to talk about, there's a few methods on how to do this. So what does it look like? Here's our database. On top of that, we have a layer called ADO.NET, which is the .NET layer, right? On top of the .NET layer, we have entity framework. So normally, let's talk about how it really works. If we use data sets, it's just ADO.NET, come directly to the database. And that means I have to use, I can use LINQ as well if I really want to, but for the most part, I have to use the old ADO.NET language, the low-level language to connect to my database, which means all the class information, all the coding, I have to do all myself. I have to structure the entire application myself, and I'm going to do it over and over again. If you and I work on the same application, doesn't matter, we're going to do this over and over again. Why not scaffold it out? Why not make it easier for us? Because we're going to do the same operation, and that's what Entity Framework does, right? Entity Framework is a middleware. That's what it does. It connects the application with ADO.NET and makes accessing a database easier and far more powerful. It has higher level methods and classes that we can use to connect with ADO.NET and keep it object-oriented, right? As opposed to functional. All right? So there's a few approaches that we can use, okay? If we're connecting, and this, by the way, the most popular approach is database-first approach. Why? I already have a database. I'm going to use a database-first approach. I have a database first, and then I create my code from the database, all right? That's the most popular way of doing things. Second most popular way, code-first approach. I don't have a database, right? And I want to use my code. I want to structure my class. There's no database yet. There's not even a table, right? And Entity Framework is going to go and create a table for me with the exact parameters that I need to run my class. I create my class first. So now we're talking about design issues. When we start talking about object-oriented design, right, I'm thinking about class-based or object-oriented first design when it comes to making table structures, right? Code-first approach. Let's abstract it even one level further. Take it back one level. Imagine us drawing out the model. Well, you can do that too. There's an entity data model that you can create, and the entity data model happens in an EDMX diagram, right, where you actually create the relationships between tables, right? It's all graphical, right? There's no code at all. And what it does, create creates the code and the table in the database, right? That's what it does. This way of this method has been becoming more and more deprecated, right? We don't use it as much. We mostly use the code first approach or the database first approach. Now, the most popular way that I like to use is code first from database, right? How does that work? Got a database, create the code from the database, and then bam, we have everything that we need to connect to it, right? The database first approach, not only does it create the code, but it also creates the model. It actually creates the diagram too, right? And a lot of times we don't need that. We don't need the diagram anymore, right? If especially when it comes to getting out rolling fast, like what we're doing here with rapid application development. By the way, the exact same stuff I'm talking to you here is going to be the exact same things we're going to learn in COMP1007, enterprise computing. I'm just putting it at a high level right now, but you're going to hit it again in the summer. All right, so it's not the first or last time you're going to be using link and entity framework, right? So whether you're using the web or applications frameworks, we're going to use the same frameworks to connect to data. All right, so here's the database first approach. Again, like I said, it'll be used with an existing database. We use an idea of an entity data model that will be created from the database, which means like it's going to look like a schema, like a drawn out schema. That's what it looks like. And then what's going to happen is from the schema, it's going to create the code. Best suited for applications that already have an existing database where you want a diagram as well. Okay. Code first approach. We don't have a database at all, and we write our own classes. And what it does is it creates a database for us. This is a very popular approach when creating new databases. Model first approach. If you're a business designer, you have nothing to do with data, you don't know how to code anything, right? But you just want to talk about the relationships between one table and the other. You draw it out, a UML diagram, right? Inside Visual Studio, creates the table, the class for you, and bam, also the table in the database. Very popular for those people who want to do that. Normally for us, we don't do that kind of stuff. And from a code first from database, which is again my favorite approach, which is basically what you're going to do is you're going to generate code first context from already an existing database. Well, we don't have a diagram at all. This is the one we're going to use. Code first from database. Okay. So that's the high level concept stuff we're going to talk about today. Now let's get to actually some examples, right? Last week we were working with a project. When I'm looking at the COMP1004 folder here in my convoluted mess. Here it is. Actually, this is not correct. Let's just pull it up. I'll pull up Visual Studio. By the way, anyone download Visual Studio 2017? It's out there. You can get it free from E5 on the hub if you're interested. Is there an advantage using Visual Studio 2017 right now? Well, there's certain things you can do with 2017 that you cannot do anymore with 2015, right? What kind of things can't you do? If you're using entity data, the new entity framework comes with it. There's also something called MVC Core, which is out there as well, right? If you're building out web applications with the new core framework. Again, there's the new core framework came out with 2017. There's also a bunch of extra little features, and eventually we're going to migrate from 2015 to 2017. Will it happen this semester? Hell no. I'm not touching anything. And please don't do that. If you've already downloaded 2017, if you're watching this and downloaded 2017, that's okay. But if you haven't done it already and you're tempted to, please don't. Please wait until the end of semester before you fool around with your IDE. That would be very bad for you if you're working with something. Also, it makes it very incompatible. Now, worst case scenario, if you already have, I already have 2017 loaded on another system, I could always read your stuff. Okay, but I don't recommend it. So we're working with COMP1004 lesson 8, and what I'm going to do is I'm going to take lesson 8 and spin it out, and turn it into lesson 9, like we did before, by creating a template. Again, just like we did last time, if we have an exam in this course, see how I said that? If we have an exam in this course, right? Because I'm trying so that we don't have a final exam in this course. I'm trying to do that for us, right? Because I think it's important for us to try and avoid doing that as much as possible, especially since we have 5 assignments, right? And our 5 assignments are going to be each 15%. So that's 75% of our marks are going to be in assignments. Think about that, right? 20% we had in a test, which is 95% of our marks, right? Do I need a final exam? Well, I have 2%, 2%, 2%, 2%. I got all these little bonuses, and if you did all the bonuses, you're exempt from doing the exam, right? If you didn't do the bonuses, you may want to come in, right? I might just declare that there is no exam, right? And we'll just go with what it is. I'll mark you out of 95, right? That might be the other way to do it, right? Which means if you got 92 out of 95, that's your marks, right? We might do it that way too. So stay tuned. That's where we're going towards. I probably won't have to do a final exam in this course. I don't like doing final exams in general, only because I think they, especially from a practical course like this, we've done so many assignments. Yeah. Yeah, I got to put it up. Thank you for that. I will put it up later on. Please remind me during the break. I'll put it up. I have it. Okay, so what I want to do here is, let's just close this down. Right, so this is just what we had done last time, right? And what I want to do is I want to go File, Export Templates, just like we did last time. And notice that it's a project template, which this project right here, next. And I'm going to call this Lesson 8. Sure, it doesn't matter. And I'll save it. Finish. That's all it takes. It'll generate the template for me in the background, and when my File Explorer comes up, right, then I'm going to be able to, I know I can use the template. And I got to wait a bit. It doesn't show anything here on my virtual machine, but there it goes. Once I see this, I know that it's done. And for you, you just might see the actual template name in a zip file. File, new, or sorry, I'll say a closed solution. File, new project based on my solution I just opened. All right, so I just made, and I'll put it up on GitHub immediately for you, right? So you can see it. So concept-wise, you know what? You've got everything you need to use the entity framework. Now we got to practice with it. We got to try it out a little bit and see what we can do, right? So there's two parts. There's link. We want to talk about link today. I want to talk about entity framework to help you. Next week, we talk about file input, output with files, right? Which is the last part that you need for your assignment, right? So I'll cover everything you need. All right. So again, I'm not going to just do a Windows application. I'm going to look at C#, scroll all the way down here until I find COMP1004, which is probably past it. Here it is. And Winter 2017, Lesson 8. This is the one I'm doing. I'm changing this to Lesson 9. There we go. And using a Git repository here, I'm starting off with the exact same lesson as before. In this case, what I'm going to do is under changes, there are no changes, right? But what I can do is I can immediately put this up on GitHub for you guys by clicking on Publish to GitHub. And I'm going to go to the Georgian College organization I created and click Publish. So it's going to be COMP1004 Winter 2017 Lesson 9. And we're going to check that to see if it's correct, because sometimes Visual Studio has a wonky way of making things not correct, right? So if I'm using the IDE, it's not always perfect, right? So how do I check that? I'm going to go to this, and I'm going to go check my GitHub account, right? Here's Georgian College. And let's see if I have that thing I just made, right? So I went make Lesson 9. There it is up on GitHub. And if I look through here, it says Lesson 9. That's important. If it said Lesson 8, that'd be bad, right? But it says Lesson 9, so it's up on GitHub for you. Cool. So what do we have so far? Right now, we have this single file, right, that we had, right? This is our example we ran with last week. And all we did was pull some names down from a database that's running locally. Okay, here's the database that's running locally, and I got some names. It's a names database. Cool. But the problem with this approach is, and I'm just going to put this out to you. The problem with this approach is we're filling the database, right? And we're using the old way of doing the database, right? The old way. So let me talk about that. So if I go into my Solution Explorer, and if I look at my data form, here it is. And if I look at the data behind, the code behind the data form, so if I look at view code, you can see that, first of all, I'm using this particular piece of code that connects to a table adapter using ADO.NET, right, where I connect to my table and fill my data, right, that comes from the users table. Okay, old way of doing things. Okay. I'm not going to kill my data store right now. I'm leaving it like as is for now. We'll come back because I can use both if I really want to. Not recommended, but let me just put both in there for now. Okay. What I want to do is I want to use entity framework to connect to the same data store. So let's do that part first. What is it that I need to do to set up the entity framework for my application? And hint, hint, guys, I recommend this. However, I'm not going to force you to use the entity framework to do your assignment number 4. If you really want to use ADO.NET, go ahead. It's just going to be a lot more work for you, okay, in some ways. Okay, so how do I do that? So first of all, I want to add it in. So I'm going to go here, and I'm going to do a couple things. I want to click on Add. Follow me here, because this is a good exercise for you guys to do with me, right? Add. And I want to do a new item, right? So I'm adding a new item. I'm clicking, first of all, on my project. So there's two parts. There's the solution itself and the project. I'm clicking on my project and clicking Add, and I'm clicking New Item. Okay, cool. The item list is going to come up. This new item dialog box is going to come up now, right? And the new item dialog box is going to show me a bunch of different options, okay? What we don't want this one. We want data. So click on data, please. And notice there's a bunch of different things here that we can select. For example, an XML file, an XML schema, entity framework 6, DBContext generator. Nah, we don't want that. A data set. We've already done that one, right? We did it automatically when we used our smart arrow instead of our data grid, right? But here we're going to use entity data model. The first one. Notice the bottom. It says model 1. This is incorrect. Please don't leave it as that, right? We want to change this to a context. And I want to talk about what a context means. The context means, what am I really connecting to? I'm connecting to an entity. And I want you to think about an entity as some kind of table structure, okay? And this entity data model, right? This model is it has its own context, if you will. So I want to connect to maybe more than one table. In this particular case, we have only one table in our database, right? Our names table. But I might have a database that has a lot more in it. Like, for example, names. I might have a names table. I might have games. I might have books. I might have a bunch of other stuff that's in the different tables that are in the database. A good example of this, if I was going to visualize in my head, would be if I had my own school, right? And I have students in the school, and I have teachers in the school, and I have courses in the school. What's the context? Is it teachers, students, or courses? What is it? It's school. That's the context, right? Because I have in my school database, my school DB will be the context. I have students, teachers, and courses, right? Here, I only have names, right? So I probably can call this the names context, and which is what I'm going to call it. So names context. I'm going to put it like in caps here. And click Add. It's going to pop up this little thing. Okay, remember what I talked about? Quiz, pop quiz here. Which one should I use? Designer from database, entity framework. Which one? The last one, right? Code first from database. It even says exactly what it's called, right? Code first from database. I want to use this one, right? Okay, so that's the scaffolding approach. That's what I'm going to use to scaffold out or generate my code for me. I don't have to generate my code. It's going to make it, right? And this is perfect for your assignment number 4. Why? Because you have this massive order list, right? And this way, it can be passed this way through some kind of class, right? A model class that I can use. Okay, cool. Next. All right, it's going to say, do you want to use the same connection string? Right? And the answer is going to be no. I want you to see what the connection string looks like. You can have multiple connection strings here. I'm going to say new connection. I'm going to connect to the same database. Remember, it was local DB. That's why I connected to it, local DB, right? And then /MS SQL local DB. That's what it was. And if I did this correctly with Windows authentication, and if I did this right, I should be able to kind of open this up, and it should show me a list of tables, right? I want this one, COMP1004 W2017, right? That's the database. Okay, if I can't get this, right, that means this is incorrect in this case. Or if I was using the database online, I'd have to use SQL Server authentication. My username and password could be incorrect. Okay. This is local, MS SQL local DB, points to my local simulated or SQL Express server that's running on my computer. Okay, that's what it is. Cool. Let's press. By the way, did I press test connection? No, because I don't care to test the connection. If I can do this, I've tested the connection. So it kind of is redundant, right? Press OK. Now notice it's a different connection string. One COMP1004 games connection string. It's going to change to VM, Windows 10, local, DB, blah, 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 DBO. That's fine, right? And notice it says the data source is MS SQL, local DB, right? And this is the names context. Well, I already called it names context. I don't want to use this because this is what's going to be in my app.config. And I want it to be called, I want it to call something, I want to use the word connection in my app.config, like the names context connection, which might be what I want to call it. So at the very least, please add connection to the end of this. Names context connection. I know it's long, but who cares? Then press next. Now, look what it gives you. It gives you a little list of things you want to include. Now I only have one database here, one table. I only have the users table. So click onto it and press finish. Now, one more thing to notice is down here. If you press finish already, it's okay. Look, take a look at this. It says pluralize or singularize generated object names. It's going to generate a list of users, right? The name, the actual table is going to be called users. That's what it's going to be called. But my object is going to be called user object, right? So finish. It's going to do its dance. You got to let it spin for a second. It's going to download and install the entity framework, okay? Because the entity framework is not part of our application structure right now. But it's doing that, okay? Finally, it ended up with this. Here's an example of what it's done. Here under references, notice what it did. It included the entity framework, which it downloaded through by using the NuGet package manager. It went to the package manager, the one that's built into C# for getting packages, right? Front-end packages. It went out there, grabbed everything, and put the entity framework into our application. Okay? It also included some other things. But for now, this one is the most important one, the entity framework, which it included. Cool. Not only did it do that, take a look. It also added this other file called names context, right? But if you look underneath names context, you can see that there is it is a class names context, right? Look. Okay. And it added it randomly here. It's okay for us, for our purposes, names context, right? So what did it add? What do I have in my names, right? This context is, I need a context class because the context class, again, remember what it is. It's not just for my little table. It's for all of my tables, okay? And we're going to redo this one more time. I'm going to do another example because this is not enough, okay? I want to do another example. I want to do that school example we talked about, okay? Because that's more interesting. It's more complicated, and you're going to need to do that with something that you've done later on. Okay, so that's one of the things you have to see. That this is like you've got your names context, right? And you also have a user class. Take a look. Here's my user class. And if I click onto it, hey, look what this is. I got my user, I got my integer, an int ID, right? And a first name and a last name. I didn't have to go to the database to check out what it was. It went there by itself and scaffolded the entire class by itself. Hey, guys and girls, this is way easier for me than making your own class, right? So now that I've got my user class, I can use it to access the database. Okay, this is the first piece. Notice what it's done here, just to go up and show you this, right? It included the component model data annotations, which is really important, right? These square brackets here, if you've never seen them before, what they are is they're modifiers on each of the properties. They can also modify each of my classes or methods, right? In this particular case, when we use annotations like this, data annotations, we really specify limitations on my framework to say something like this. Hey, my first name is required. I can't go without a first name, right? When I enter data into the database. My string length is 50, right? The size of the value that I'm going to put into my name can't be greater than 50. And I made a getter setter. And same thing with my last name. First name, last name is all I'm storing right now because we made a very simple table. So I have two parts. There's the data context, which is this part, right? Which talks about notice that there's a DB set called users. That's the table, right? So that's what this is. This is the table. So I was going to talk about the table in the database, whatever that is, right? Okay. Table in the database. And notice that the name of my context is names context, which derives itself from DBContext. DBContext is a superclass, right? That's the class that basically connects us to the table. If I want to connect to the database, I haven't connected to the database here. I've just got classes. I got a class that can connect me to the database. This is all the connection details. Take a look. It even tells you names, context, connection, right? So whenever I create a member of this DBContext, right, it automatically connects me to the database, right? It's nice and beautiful that way. I don't have to sit and go, database open, do this, right? I don't have to do that. It does it all for you, right? And then my data class, my users table, right? My user table, what it does, it specifies the way I can carry data from one object to the other. Very simple example, right? Okay, let's see how we can use this thing in our form. Right, so in my data form on the back end right now, first of all, notice that I already have link by default in my form. This is how link looks, system.link. I haven't used it, but I've already included it as an object that I can use. Notice the ones that are grayed out. Here's the ones that are grayed out from this using statement on down, these ones here. These using statements are by default added into my form, but never used, right? That means I'm accessing libraries saying, hey, I might use these, right? And we're probably going to use a collection. That's why it's included. And we might use some kind of data access. And guess what? We may use link. So put them all in there. And that way, the user doesn't have to go and find them all, right? But the other ones, the entity framework and all the other stuff that I want up here, that I may have to do. And there's two pieces that I can use to connect to the database, which I will in a second. So first of all, without touching anything else, I've added a whole other library to my application. Can I run my application as is? That's the first thing. And if I look at my app.config specifies the connection strings that I have. Now this is very important to look at because it looks like to me that I have 3 different little connections here, right? Here's my name for COMP1004, W2017, Lesson 9, Property Settings, COMP1004 connection string. Woo! Then I have another one, COMP1004, W2017, Lesson 9, Property Settings, COMP1004, W2017 connection string. Whoa. And then I have this one. This bottom one here, right? This one here is the entity framework connection, where it says, hey, connect to this thing. This is the names context connection, right? Which creates a connection to the database itself. Notice that all of them, the provider name is important when they're in our connection string, which is the SQL client. Now this one here, notice that I have a username and password. This is because I tried to connect to a database that was on Azure, right? And it failed. So that's why I'm not going to do that today. Next week. Today, local. Let's try that out again, right? But this one here, the first one, if I wanted to, I could take it out because I'm not using it. So I can go here because I'm not using this first one. I can just erase it. Okay. And if I do that and save, right, and run, just run it as is, I should still get the exact same stuff like I got last time, right? Same exact thing and no errors. If I click out of this, it just closes, right? Notice that it takes a bit of a second to close down because I got a couple of connections happening to the database, right? It takes an extra second, right, when I stop my application. Questions so far on how to connect. All I'm doing is adding the entity framework. Okay, that's all I'm doing. Again, if I had more data or different tables in my database, and I'm going to show you that again, I could see a different kind of context, right? So we'll do one more little example before we stop, because I can have multiple, right? Multiple connections. Each connection will be for a different context if I want to. So I can access different databases if I want, or different sets of tables. For example, if I want to manage users, I might have something called the user context. And maybe I have a bunch of tables that keep track of user data. For example, an administrator table, the actual user table itself, a roles table for what kind of user roles I might have, and so on. And that could be those three tables could be part of my users context, right? Which is just those three tables that I need to do any kind of user management, adding users, just subtracting users, changing user passwords, adding different roles to users for authentication and authorization, all those kinds of things. That could be a whole other thing if I want to. So let's add another one. And to prepare ourselves for adding another one, for this example, I'm going to go into SQL Server Object Explorer here. And in my local DB, MS SQL local DB, this one here, where I'm going to open it up, and I'm going to go to my databases. And I have this long list of databases I was working with. One of them is COMP1004 W2017. That's the one I created locally. And I have one little table here under my tables called db.users, right? I'm going to add a few more. Let's add 3 more tables. I'll add courses, right? Students, okay? And maybe departments. So maybe, the computer science department, department name, and I have courses attached to that one with a course ID, and so on. A bunch of other things here. Let's figure this out here for a second. So let's add them in. So here's users, that's one thing, but I might have other ones in. So I'm gonna add a new table locally here, and just using the same syntax we did last time so you can see how this works. This is my table, right? Notice that my create table, dbo.table, I wanna call this the courses table. There's my courses table. And my primary key, I can start by doing this. On the right, I want to definitely bring up my properties, right? So, because right now, my properties are down here. I can bring them up so you can see them, right? My properties are context sensitive, so whatever I click here, it changes what I'm looking at over here. I definitely want to use that my identity specification, instead of being false, when it allows me to, I want to change this to true, which makes it so that this is an auto-incrementing table with a primary key. It cannot be null, right? That's what this does. I did this last week, but I want to do it again so you see it the second time, right? All right, now for our names in the table, for our fields, what other fields do I need? For courses, it's a courses table, right? I might have the course name, right? So, or a course ID, like an actual course code. Maybe that would be something I could call. So I could say course code, right? The course code, definitely nvarchar. If we're going to choose something, nvarchar for the course code, maybe 50. Sure, that's fine. Can we allow null? Absolutely not. It can't be null. We need a course code. How about, can we also have the course description? Short description. Short description. Kind of a longer one, right? Course short description. This one's got to be a little longer because that might be something like, intro to graphics or something like that, right? So the course code, intro to graphics. Okay, cool. And then, now some people might also call this the course name, but this is like the short description really at the end of the day, right? So we're going to kind of go in here and go nvarchar again. I'm going to go nvarchar 50. I don't think it should be much longer than 50 or 100. If you really want to change something, you could go in here and change the values. If you want to make this 100, so like double length, you could, no problem, right? Can't be null. You need these two things for sure. Course code, course short description. What about things like credit hours, right? Number of credit hours that the course has, right? So we'll just call this, credit hours. This would be a number, right? Because you want to kind of add up your credit hours at the end of the day, see if you have enough. So you probably want to make this something like int, like an integer number. It can't be too small. Now there's big int, there's binary, there's all kinds of stuff, but int will do for this one. Can it be blank? No. So that's it. So course code, course description, and for now, and credit hours. How about, right, courses have students, right? Courses has a one-to-many relationship. Actually, it's a many-to-many relationship. I can have students has many courses, and courses have many students, right? Does that make sense? So it's a many-to-many relationship between students and courses. So I could create another database called students, which has, an array. It's an array of courses. For now, let's leave it alone. But let's make another table. So this is one table, right? And I'll save this one. Actually, I'll update the table. I'll add it in. So here it is. And we'll update the database right away. We'll add that table in. And there's the courses, right? And you know what? Just to make it interesting, I'll add some course data. So I'll go to View Data. And inside there, I'll add some courses. So the course code, let's do some courses that are here. Comp, as an example, 1004 is our course. The course short description would be Rapid Application Development. And credit hours would be 3, right? 3 credit hours. And then let's do another one. Notice that the ID gets updated automatically, right? So 1. Let's do another one. We'll say Comp 2007, Enterprise Computing, and then our credit hours will be 3. And let's do another one. We'll say Comp 2068, say Advanced Web Programming, and we'll say credit hours 3. So a few courses there. Okay? And let's do the same thing with students. Let's add another table with students. So again, just to show you this again, right-click, add new table, and we're going to go in here and do the same thing with the trick. Now, could I type it in here if I wanted to? Primary key. Could I type in identity there? Could I just type it if I really want to, right? Good. Can I change the name here from table to something else? Students. Good. Right? And it's not, I don't allow nulls for this one. So this is 1, right? So I'm making it so that there is no, this is one primary key, right? That I'm using. And if I click onto the primary key now and to see what it says identity specification true. So I can also type it. I don't have to just use the automatically stuff. Anything that you want to do, any query that normally that you can make to make a table, anything is good here. Okay. And let's continue on. So let's go with the student. So maybe the student itself has a first name, last name, right? So we'll say first name, right, which is mvarchar. We'll make it really long, mvarchar 50, last name. Not to be confused with users, right? That's a different table. mvarchar 50, and these cannot be null. And maybe some kind of student ID. Student ID, which maybe will make it so that it is can only be mvarchar 10. So there can only be 10 characters for the student ID. I don't know if it's that. I don't know if that's true or not. I think it is. 9 actually, but let's make it 10, right? So we'll make it mvarchar 10. Let's go in here and change that, right? Not a lot of nulls there. So first name, last name, student ID. Maybe we also have, maybe we want to have other information for the student, like date of birth. So we'll say DOB, which is going to be a date, right? So we can go down here and see if there's a date, right? Here's date. Now, we got to be careful about this when we use this because this could mess us up, right? Date, allow nulls. You know what? I'm going to allow it. I'm going to say you don't have to know the student ID right away or the date of birth right away if it's optional, right? Okay, so some stuff like this. So we can put other information here. So we have another table. We're going to update the database. We're going to click Update Database, which is going to add it in, and we're going to add a couple of students, right? So let's add them in by looking at View Code, or sorry, View Data. And let's add the first name in. So we'll do the same thing. So James Bond is a student here. That's it, right? And his student ID is 100000007, right? 007, right? Because that's the way he is, right? It's the first student, right? 007. And his date of birth is not necessary, so we're going to go down here. There it is, the first guy. We'll put Peter Parker in here as a student as well. Parker. We'll say 1000008. Sure, he's 008. And we'll also go, by the way, the student ID could be anything. It doesn't have to follow a sequential number. We'll show that because we can also have Tony Stark in here. Stark, where he is 1100100, right? Something out of sequence, right? Doesn't matter, right? And we have a few students. few students, a few courses, right? Now, what are we missing? We've actually called these the courses and the students ID, right? So I could make it so it says users.id or, you know, courses.id, student.id, right? I could have made it student ID, like the whole name could be student ID, the whole, and that's not a bad thing either, but ID is fine too. All right, now that I've got some data and I have some stuff in the database, as an example, this is all example stuff, guys and girls, right? It's just for us to connect to, right? We have two connections. I'm going to make another connection, right? Yet another one. Okay, let's try this out. All right, so I'm just going to get rid of all this. Now, this is the right way to do it. I'll show you the better way to do it. The one way that I showed you already was just on the actual project itself, right? But the right way to do it is actually to create a models folder, okay? And this is what I would rather recommend that you do. So right-click on the database, or sorry, the project, click Add, New Folder, and we're going to call this the Models folder, right? My Models folder. And I want to, in my Models folder, I want to have all of my classes that are relating to connect to the database, right? Cool, I like this. This is nice, nice. And now, instead of clicking up here and adding my data connection, I'm going to click down here on Models. I'm going to right-click on my Models, and I'm going to add a new item on my models, which is still going to be data, ADO.NET entity data model. And what am I going to call this? Schools context, right? Or the school context, because I have a school, courses and students, right? For now, I could have put departments. I could have made other things too, but for now we have two, and that's enough. Let's just show you this. So here's the school context. This is the other example of how to connect to the data, to the entity data model, right? I'm going to click Add, School Context, right? And then I'm going to choose this one again, Code First from Database. Click Next. And now instead of choosing this one, I'm going to make a new connection, brand new again, like we never had it before. Of course we have it, but I want to show you this connection string over and over again, see how it works. And from here, I'm going to go local DB /MS SQL local DB, right? To test it, if I know if this server name is correct, and if you're connecting with the proper user and username and password, right now I don't need one because I'm just connecting locally, then I can just pull this down. I should see a list of databases, which I do. This one's the one I want. And inside this list of databases, I'm going to see a database or a couple of tables. Let's continue, press OK. Hey, it's going to say, do you want this old thing, this old connection? This is the new connection string. I want to save it, and it's not going to be called school context. I'm going to call this school context connection. Or you can also call it school connection. And then press next. And notice that I have tables, but I have three tables now, right? I have courses, students, and users, but I'm not going to choose users. I'm just going to choose courses and students, right? And then I'm going to allow this to be turned on and click Finish. Now, it's going to go out, check to see that I have my entity framework. It's already there, so it doesn't have to get it from me anymore. And then it's going to create a new school context with two DB sets, right? One for courses and another for students. So the context binds my database together. It basically says this is your database. It has two tables. Actually, it's not true. I have three tables, but this context, I'm only using it as a group for grouping two tables together. Okay? And look, it's underneath my models folder where it belongs. It's not out here in no man's land, right? Where it's up on the root. Okay, this is better, right? Oh man, what the hell happened here? Look how it said course. It's singularized, right? This is wrong. How do I change this thing? Rename, right click, right? Rename right away before we do anything. And change it from course with an S to course with an E, and press enter. And it's going to ask you, do you want to perform a renaming? Absolutely. And what it's going to do is going to go down, and notice how it changes it from a DB set, which is a list of courses of type course with a single S to a course with an E. I brought that in case, just in case you make a, some kind of thing with invoice or some other weird thing, and if it takes it away, or orders, and somehow it changes it to order, and you don't want it that way, you can always change the name of your list to whatever you want. Okay, cool. So I've got course and student. Those are the two objects, the two classes, the course object and the student object, right? And let's see how they look. Here's my course object, right, where I have my ID, right? Notice it says table courses. It specifies what the table is. That's the annotations. Data annotations. I can modify my class. I created a class here called course, and I'm using the table annotations to point it to the table courses in the database. That's what it's doing. I need an ID. This ID has to have capital I, lowercase d, or capital I, capital D, or it has to have something like whatever the name of the table is, course ID, capital I, capital D, or course, capital I, lowercase d. Microsoft searches for it. If it doesn't, you can specify a key. For example, if I go here and I press my square brackets and I start typing, notice that I can actually choose key as one of the data annotations. I can specifically say that my ID is the key, primary key for this table, if I really want to. So that means I can have a primary key that's not called ID. It can be called whatever I want it to be called, right? And which is a lot of flexibility, again, when it comes to how we connect to the database. Okay? And then let's take a look at our student. Student's a little different too, right? Student has a bunch of other stuff here. Notice what it did with date. Type name is equal to date, right? And then it says date time with a question mark. Question mark means optional. It's not required. Here it's required. 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 Here with the question mark in C# means that you may or may not have a value for this date of birth, right? So, and when it comes to optional values, we can have optionals in our classes. Optionals means we may or may not have a value for the property. Each object has that property, but it might be empty. That's what it means. Optionals are very modern nowadays, especially with languages like Swift, which uses optionals all over the place. If you program anything with Swift and iOS, optionals are used constantly, and you have to wrap and unwrap them. That's a topic for another day. All right, so here I can also, again, specify my key if I really want to. I don't have to, but I'm showing you that I can do this here because this is like primary key for my table, and I'm good to go, right? Now here's the difference here. This student, right, student and course is inside models, which means for me to access student and course, I have to include the namespace, right, inside my my classes that use it. Because right now, if I try and access it, so I'm going to kind of say save this, and if I'm going to say save this, and if I go back out to my data form for a second, here it is, and if I go back to look at the code for it, so if I press F7, here's F7, and if I start specifying when to connect to it, well, just somewhere in here, let's say inside my class, my form itself, I want to make a connection to my database, right? So the way the connection string works is like this. I indicate the name of my connection string. I have two connections that I can tap into. One of them is called school context connection, and the other one is called users connection. Let's do the first one. So I make an object of type users connection. Oh man, what's happening? How come it's not? How about users context connection? How come it's not? I can't find it. It's inside here, and I don't understand. How come I can't access my users context? Well, remember where I have it. I have it in my users context is sitting right here. My name context is what it's called. So I'm calling it something totally wrong. So let's try this out again. So if I start typing name context, here it is, name context. We're going to use this as our database. So this is our names database. That's what we're going to call it. Is equal to a new, right, names context. Yay, I've connected to my database. Done. Seriously, that's what it is, right? And if I want to do the same thing with our other one, our school context, right? I have to do the same thing, but it won't work. So here's my school context, school, right? It's called school context for sure, right? And if you want to look at it, it's inside my models folder, right? School context. So if I start typing that out, school context, and I'll say my school DB is equal to a new school context, right? How come it's giving me an error? Because inside the models folder, right? So I have to give it some stuff, or I can let Visual Studio do it for me, right? And if you notice, if I kind of click on this thing here, right, and I press Control dot, it'll give me some suggestions. It'll say, hey, add a using statement using COMP1004 blah, 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 blah models, right, which is the right thing to do. If I do that, double click, it adds that in as a using statement right here, right? Now I have access to the models folder, and it comes up no problem. Does everyone understand that? So that's the way I can connect to my model that I've created. Now I have access. Guess what? Names DB and school DB, right? Well, I can do all kinds of statements there now, right? Like, for example, if I want to have access to all my a list of users, and I want to do it here in my data form load, right? Let me just kind of go out here for a second. So here's my data form load. I want to get a list of users. How do I do that? Well, I can say, I don't know, I'll call it var, just what you saw, users list is equal to, and I'm going to put this in brackets here for a second. Right? I want to kind of think about this, right? So I want to use a from statement, right? So from, right? Is that the first one? Is that the first from blank in blank, right? So from user in, that's the keyword. Notice how it turns blue, right? DB, right? So it's users DB or users list. That's what it is. But what did I call it? I call it the names DB, right? Names DB dot users. Names DB's database uses the table, right? Names DB dot users. What do I want to do? Select user. Select all the users in my database. That's what this is doing, right? So this one here selects all the users in the users table of the names database. So it does. But however, if I hover over users list, it gives me something called an iQueryable, right? An iQueryable doesn't do anything for us, right? At all. What I'd rather do is make this into a list, right? Because if it's a list, I can add users, I can subtract users, I can do a bunch of stuff with users. It's a list, right? So how do I do that? I can do one of these. I can say dot to list, right? And guess what? Now, if I hover over it to see what kind it is, it's a user list, which is a type of list. And now, my friends, I can do any list operation that I want onto the users that I return from my table. Okay, to show you this, what it looks like, I want to show the list. Let's print out this list onto the console, right? By the way, I can use debug. Remember debug.writeLine? I did that one time already. I can do it again. Debug. One day when my VM lets me. Debug.writeLine. If it doesn't show up, you know what I'm going to do. And what I want to do is I want to print out the user that I'm looking at. But notice I can't do a debug.writeLine because I'm not using my debugger yet. So I'm going to press Control dot to add in users using system diagnostics, which allows me to do my debugging, right? And what I want to do is I want to wrap this debugging statement inside of a for each loop. So I'm going to say for each, right? Here's my for each. And I'm going to say for user, lowercase user again, in the users collection, the users list collection, right? So this is a collection now of users, right? I can debug.writeLine. And inside the inside my statement, I want to show the user dot first name. How beautiful that is? So I have direct access to my data members, which is a beautiful thing, right? Once you have access to this, guys, I'm showing you a nugget that you can use, right, through any .NET application, whether it's web application or Windows Form application, or even the most modern core application, once you have access to this and using a link combined with Entity Framework, you have access to all your data, right? In any way you like. So let's see what this does now to test it. So I'm going to just run it and see if we get an error. So, bam, bam, bam. And notice on the bottom here, I get Tom, John, James, Jane, Matt, and Peter, right? That's our first name, and I got it right from the list. And again, think about what I just did, right? I went, queried the database using my link, not using ADO.net. The other way, filling this table, I didn't fill this table with that way. I filled this table with ADO.net, the old way, right? But I was able to get all the data, the users from the database using Entity Framework and link, which is what we've been talking about this whole hour and a bit now. Hour and a half, actually. Okay, makes sense? One more test, and then we'll stop, I promise. All right? Let's do the same thing, but I don't just want to get the users list. I want to get the, I don't know, course list or something like that. Why not? Because I have access to that too. So I'm going to do the same thing. I'm going to say, well, var my course list, making this up, right? Course list is another variable. I'm using var because I don't know what the type is going to be yet. I'm going to use from course in, and again, school DB dot courses. There it is, right? Select course. All my courses. I'm going to pass this to list, right? It's exactly the same way. So we're seeing it done twice for us here, right? There we go. And then I can just do a for each, where my var course in, which my course list, there it is. And I'm going to say debug dot right line, and we'll say our course dot course short description. One of those, right? See, that comes right from the database, right? It's not easy, right? I know you guys are like saying, he says it's easy, but it doesn't look easy, right? It is. Trust me. If you try it out, if you use this stuff, it's not that difficult what I'm showing you, right? I'm literally connecting to the database and getting data from it. Once I've got that, guys, you're golden. You can do anything with that data, right? Put it inside of a form, translate it, add it together, add a new user. We can do full CRUD, which is what we're going to do later on. All right, so let's just run this thing and see if it works. And we're loading up, and now not only do I get Tom, John, James, and whatever, but I also get rapid application development, enterprise computing, and advanced web program. It's not showing here, but I'm accessing another table from another database, or another part of the database, through using my school context. Okay? Why am I showing you this? Because you're building an order system, if you think about it, right? The order, each of the rows inside of your data grid that you're going to build for assignment number 4 is going to be a computer order. You're ordering a computer part, or a whole computer, if you will, right? The computer itself, the order, has an ID. It can have a bunch of stuff, right? And you can order everything up. You can create the structure like I've done, right? And so that you can access it, save it, play with it, add it, delete it, do whatever you want with it. For your purposes, for assignment 4, you do not have to do full CRUD. All you're doing is reading right now. We're going to do full CRUD in the summertime. When we access the Entity Framework, we use it to access our enterprise computing. That's when you can do full CRUD. Today, we're not going to do that. All I care about is for you, can you read the database? And the answer is yes, you can. Right? Because I've shown you how to read it in a number of different ways. Can I filter from the database? Okay, I want to get, a specific piece of data. So I want to, get my user list, right? Well, guess what? Where users is equal to a username, a user.firstname is equal to, I don't know, Tom. See if I can do that. So I only want to, kind of return one user. That's a different thing. Am I going to get a list here? Maybe not. Right? Let's see if I do that. If I go where, user.firstname, right, is equal to, so double equals, some kind of value, I can do that. I can say, well, it's equal to Tom, right? And I don't want to return, my a list, I want to return first or default. First or default means I'm only looking for one item. Well, guess what now? It's not a user list I'm returning. I'm returning a single user, right? That's how simple it is to return a single user, right? So I'm not going to do this. I'm just going to, and I'm not going to call it user list. I'm going to say, let's say single user, right? And that's what I'm going to return. I'm going to return just a single user. This is the example for a single user, where single user dot first name is the one I want. Single user dot first name, right? Whatever that single user is, if it matches Tom. Once I've got that, if I can search and order and all that kind of stuff, I'm looking at that order database again on assignment 4, right? And I can search for a particular item that has certain criteria, right? And I can return it, do something with it, print it, delete it, whatever, save it. Okay. Let's try this out. So I should only get Tom back. All right, let's see if that works. And by the way, if I want to print out single user first name and single user last name, just to make it a little bit more apparent what I'm doing here. All right, so let's just get rid of this. Single user dot last name. And if I go start, I'm looking for Tom. Do I find anything? I get Tom and my last name. What about if I don't find something? What if I don't find the user? What do I get? Let's see. It's important for us to understand because it might cause us to have an issue, right? Later down the line, right? So first name, last name. If single user returns something, look what user returns, right? First or default. Default means no, right? First means give me my first iteration of something that matches Tom, right? Or default, give me no, right? Okay, well that means that both of these will be no, right? So let's try this out. So instead of having no Tom, we'll look for something weird like I don't know, Dr. Strange, right? Which is definitely not on the list. First name is Dr. Strange. That's kind of weird too, anyway, right? Actually, it's Steven. That's his real name. Come on. We're going to use this example. I mean, I got to be true to the whole thing, right? Huh? Got to do it right? So I'm going to kind of, oh, wait, look what happened, right? It said, well, it says no exception. I couldn't find a user. So what do I need to do here when I'm doing this kind of work? I can wrap it in a try catch. That's one option, right? If I wrap it in a try catch, it's going to give me I can't find my user not found, right? I could do that. I could also make it so that it is I could see if the user exists. If my single user returns something. Now it says unhandled exception of type null reference exception, which means I'm trying to access a first name that doesn't exist, right? So let's try that. I can wrap this in a try catch, this whole thing. So I can go try. Right, here's my try catch, and I can take this whole thing in here, right? And I'll cut it, and I'll put it in here. And instead of selects all, selects the user that matches, the name specified, whatever that name is. I can also use this instead of putting a literal value like this. I could put in any kind of variable, right, that matches that name, right? And then when my exception, I'll call it the exception is E, right? Or I could also call it error. But for now, let's use E. And what I want to do here is when I throw an error, I want to debug.log or debug.writeLine. I'm sorry. The E.message, right? I want to show that message. Whatever that message is, I want to spit it out. Right? No message found. Or I could specify to the user, as an example. Sorry, we're going to call this the lowercase exception. So that way it doesn't clash with anything else. There we go. Right? So if I do that, and if I try it, which is what you should do, you should put it in a try catch, right? Then it won't fail, but it'll come up and say, object reference not set to an instance of an object. That's the error. And what I'm going to tell the user is, I didn't find anything, right? I didn't find your user. User not found, right? Or it's going to come up blank. Okay, this is a great place. People are falling asleep. Let's let's take a break, 10 minutes, and we'll come back and we'll continue with this craziness, and maybe we'll try something different. I do.